This is the intro to section 3.4, part 2. Okay, we're going to take a look at this proof. Now, we're going to go ahead, we're going to cross out this second proof. We're not going to mess with the second proof. You're not going to have to worry about that one. So we're going to go ahead and cross that one out and not have to worry about it. But we are going to look at this first proof. So what I want you to do, I've written in the statements for you. Again, I want you to pause the video and see if you can come up with the reasons for this and then match with what you have. And then I'll go through and explain what the reasons are and how you come up with them. And that way you can check to see how well you actually do before you go through the answers. Okay? So make sure you hit pause here on the video. Go through and see if you can fill out the reasons. Okay, now that you've hit pause in the video, you've filled out the reasons. Let's go ahead and let's take a look now at what we're trying to do here. So on this proof, it says here, given in a plane R is perpendicular to T and S is perpendicular to T. Well, in our very first statement, we can say that is our given. Okay, that's our given statement. So what it says here is that R is perpendicular to T and S is perpendicular to T. And as you look at the picture, you'll notice that in this case T is a transversal. And we want to prove that R and S are parallel to each other. Now, before I go any further, you see that it says that it wants you to prove that R and S are parallel. Remember, there are 4 ways to prove that R and S are parallel, using the converse theorems of either corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent, or same side interiors are supplementary. That's what one of the 4 options is going to fit into this last statement eventually, depending on what information you have up here. Okay, so as we look at the proof here, in the given, remember the given is a hint. So it says that R and T are perpendicular and S and T are perpendicular. So that's going to lead you to say, if S and T are perpendicular, then that means that these angles, all 4 of these angles are right angles or 90 degrees. Okay? Over here it says R and T is perpendicular. So R and T are perpendicular. So again, all of these angles, if they're perpendicular, are going to be 90 degrees. And if they're not, and if they're right angles, you know they're 90 degrees. Now, how do you know that angle 1 and angle 2 are equal to 90? The reason you know that is because of what we call the definition of perpendicular lines. Okay? It's the definition of perpendicular lines. Some of you may have put in there, well, because they're corresponding angles. Well, you can't say that corresponding angles are congruent yet, because we don't know that the lines are parallel. Okay, so you can't say that. So you can't say that angle 1 and angle 2 are corresponding angles or congruent because we don't know that those lines are parallel. We do know that these are 90 degrees though, because when perpendicular lines intersect, 2 lines are perpendicular, they form 90 degree angles. Okay, now from step 2 to step 3. You'll notice here we say the measure of angle 1 is equal to 90, the measure of angle 2 is equal to 90. Well, if they're both equal to 90, then they're both equal to each other by what property? And this is the transitive property. Okay? The transitive property. Now, if I know that angle 1 and angle 2 are congruent or equal to each other, I can now say that R is parallel to S, because if you look in the picture, what type of angles are 1 and 2? If they're congruent, those are corresponding angles. So the reason I can put that they're parallel is by the converse of the corresponding angles theorem, or corresponding angles are congruent. Okay, that's how I know that they're parallel. Remember, to prove lines parallel, you only have 4 choices. Okay, and you can't say, like example number 3 up here, You can't say that these are corresponding because you don't know that the lines are parallel. In order for corresponding lines angles to be congruent, you have to know that the lines are parallel first. Okay? We're trying to prove that the lines are parallel, so we don't know that those lines are parallel yet. Alright, so this is an example of a proof, and we're going to go through some more examples in class of proofs that are similar to this and that have to do with chapter 3. Okay, this concludes section 3.4 part 2. Don't forget to complete your WSQ.